All right, good morning. This is my first time doing this from my phone. I actually already did this video and then my paper was sideways, so I have to restart it, but that's fine. Live and learn, right? Sometimes it's a matter of trial and error, especially in this world that we're living in. So you're just going to get a better version of this because it's my second time doing these notes in 10 minutes. All right, relations and functions. With regard to relations, we're going to talk about the vertical line test and we're going to fill some stuff in here. Before I move any further, I want you to pause me and write all this stuff down. And then pause me again, write all this stuff down. And then pause me again and write all that stuff down. Okay, let's go back here. So we'll fill in the blanks in the second line in a minute as we go, but let's talk about the vertical line test. So the vertical line test says, you probably remember this from Algebra 1, if there's any vertical line that crosses a graph more than once, then the relation is not a function. So I'm looking for any vertical line. So I'm using my marker as a vertical line, and I see that it only touches the purple one time every time I move my marker. Every single vertical line only touches the purple, the graph itself, one time. So this is a function. It passes the vertical line test. Okay. If you look over here, however, this one has lots of places where it crosses more than once. It only needs to happen one time to fail the vertical line test, but you can see that this one crosses more than once. So let me label some points here. So like somewhere around here and shoot, that's not exactly what I wanted to happen, but I'm gonna label these. I'm gonna say this is 1, 1 and 1, 3 just to illustrate a point. So first of all, we said it does not pass the vertical line test. Therefore, it is not a function. And I want to have a visual to fill in this blank here. So you'll notice here that for each of these points, the x value is the same with a different y value. And that fails. So the different y value is what's making it fail. There can only be one y value for each x value. So if you look here, each x value has its own y value. If I mark any x spot, I go up, there's only one y value that connects to that. Any x value, I go up, there's only one y value that connects. If I go over here and I pick an x value, I have two y values, and that's why it fails. So one y value for each x value, okay? So looking over here, I can see that each x value has a different or its own y value. There isn't two different y values for the same x value. So oftentimes people get confused here and they say, well, the y's repeat. That's not the problem. The problem is when the x's repeat. So do you see that here? These are the x's that are repeating. That's where we see the problem. So this one is a function because no repeats in x. So I'm going to encourage you throughout the year to make notes on your notes. I'm not going to write down every single word that I say, but it might be a good idea on this problem to write no repeated x's or something like that. And maybe right over here, x's repeat equals no bueno or something like that, okay? All right, so I want you to look at this one and tell me what you think. Okay, so hopefully you said not a function because we have x's that repeat. Okay, so it's not a function. Now, if you're not good at memorizing stuff, I'm not good at memorizing stuff either. You can always draw a picture for these, and I feel like that's particularly helpful. So I'm just gonna sketch. I'm gonna be like, okay, this is 4, -1 would be around there. Over 6 and up 0 would be around here, right? Over 4 and up 2 would be around here. And then over 1 and up 5, I'm just sketching. It's really not important that I am counting everything out. And if you see, this doesn't pass the vertical line test. There's 2 places right there. So that would be another way of finding out that it's not a function. Okay, so think about E for a second. All right, hopefully you got that this one is also not a function because these guys have the same x value. We cannot have repeated x values, so this is not a function. And again, for the visual learners, which is me, I'm just gonna draw the 2 points that are causing the problem. So let's say this is 2, 6 right here and 2, 0 right there, and you can see they're stacked right on top of each other. So it's going to be not passing the vertical line test. Oh, we didn't do this over here. Let me show you what it looks like over here. Sorry about that. So what do I need? I need some from -3 to 1, and they're all positive. So -1, 4, over 0, up 6. Oops, over 0. Ignore that. That didn't happen. That never happened. Ignore that. Over 0, up 6. Over 2, up 4. And over 3, up 5. Vertical line test passes everywhere. So these two that had the same y value, the 4, those connect horizontally, but we don't care about horizontal, we care about vertical. Okay, so that's why we can't have repeated x values. All right, so what is this graph gonna look like? Okay, hopefully you said a line. It's going to be like that. Lines that have a slope and a y-intercept are going to look like this, right? This one in particular has a positive slope, so it's going to look like that. The only line that's not going to pass the vertical line test is a vertical line itself, and the equation for vertical lines always looks like that, okay? So this one is a function. If you wanted to go and graph this using a y-intercept of 4 crossing the y-axis and then a slope with a rise over run 2 over 1, you could see that it will pass the vertical line test. Okay, all right, so domain and range. So my first question for you is, what does the domain represent? Okay, hopefully you said it's the x values. Okay. So there's 2 ways I'm going to show you to do this. First way I feel like is, well, they're both pretty visual. I want to think about, I'm walking along the x-axis and I'm looking up or down. And I want to think about, where am I going to see the graph? So if I'm way over here and I'm only allowed to look up or down, I don't see the graph at all. Okay. I start seeing the graph when I get right here and I can look down to see it. And if I keep walking, I'm going to start seeing it above now, right? And I'm still looking up, looking up, looking up, looking up, and I still see the graph. And then I'm standing right on the graph, so that counts also. And then I'm still seeing it if I look down, look down, look down, look down, look down, and then I can see it under my feet here. And then I keep seeing it. And now I don't stop seeing it right there, even though it's technically not drawn, but that arrow indicates it's going forever, right? So I need to keep that in mind, that that arrow is going forever. So that's indicating the domain values. So I start seeing it at -3. It's got a filled in dot, so bracket. And I see it for every single x value from -3 all the way to infinity. Every single x value that graph exists, okay? The range, I want to look at the y-axis, right? Oh, I put values. Let me write y values. And I want to figure out where I see it if I'm looking left and right. So these would be good side notes to put. This is looking up and down from the x-axis. This is looking left and right from the y-axis. So I don't see it if I'm down here. If I'm only allowed to look left and right, I don't see the graph when I'm down here. I start seeing it right here to the right. And I can see it, I can actually see it at 2 places to the right over there, so I'm even better. And then once I get here, I can actually see it to the left and the right, so that's even better. I can still see it left and right, I can still see it left and right, I can still see it left and right. I stop seeing it to the left, but I start seeing it to the right only, and that's fine. And it goes up forever because of that arrow, okay? So what this is indicating is I can start seeing it at -2 with a bracket. That's a filled in dot. And I can see it for every y value up to infinity. Okay. This will never be an open dot. There will never be an open dot floating randomly in the middle of a graph. The only time you might have an open dot is at an end point. So you're only going to ever have a parenthesis at an end point, okay? So I'm just going to show you one more way of doing this. If you don't like this shading method, which it's totally fine if you don't like the shading method. Sometimes I take out like a couple pieces of paper or some notebook cards or something. And I'm like, okay, I want to see the whole graph, but I don't want to see any excess. If I do it like this for domain, I'm chopping off the x-axis. Do you see that? So I'm talking about domain. I'm not looking at the whole graph, okay? So I want to slide this over until I get to the edge of the graph right there. I don't want to have excess. I want to see the edge of the graph and only the edge of the graph. So I'm going to keep sliding. And I'm going to stop right there, but then, oh shoot, that arrow was telling me it's going to the right and up forever. So even if I put it way over here, I'm chopping off that arrow at some point, okay? So when there's an arrow, you can't have that piece of paper. So what I'm looking at is I'm chopping off the x-axis, I'm starting at -3 and I'm going all the way to infinity. I can do the same thing for the y-axis. If I put my papers here, I can't see the whole graph, okay? I always try to start with the negatives. Notice I'm chopping the y-axis now, not the x-axis. That's how I know I'm doing range. So I want to go down first. I want to start with the negatives, and I stop right there. That's the edge of the graph. If I go up, I still can't have that piece of paper because no matter where I put it, I'm going to be chopping off that arrow at some point because it's going to keep going up. So I need to get rid of that piece of paper and see that this is from -2 up to infinity. Okay? All right. I'll see you on Zoom.